So question says a vehicle travels half the distance with speed v and the remaining distance with speed 2v. So if it is going from any point A, one second, let me just write here A and B. Half the distance it is going with speed v, another half it is going with 2v. You have to calculate the average speed. So average speed in this case will be total distance over total time. Total distance over total time. So here the total distance I am assuming, since it is the midpoint, point C is midpoint, I am assuming AC is x and CB is also x. So total distance will be x plus x. To calculate total time, let's say that time taken to go from A to C is T1 and while going from C to B it is T2. So it will be T1 plus T2. T1 is the time that will be equal to our how much? Distance upon speed, correct? So x upon v, and T2 will be equal to x over 2v. So straight away you can substitute here x plus x over T1, which is x upon v, plus T2, which is x over 2v. Now let's take common out. So here x plus x, it will be how much? 2x whole divided by, taking x common out, 1 by v plus 1 by 2v. X gets cancelled with x, we left with, now let's take v also common. So 2 upon 1 by v taking common, it will be 1 plus 1 by 2. 1 plus 1 by 2 is nothing but 3 by 2. So that will give us 2 over v into 3 by 2. And that will be how much? 1 by v is taking common. So here v will go on the top. So that will be 4v upon 3. So correct option is option B. Person traveling in a straight line moves with a constant velocity v1 for a certain distance x and with a constant velocity v2 for next equal distance. So let's say here our A point and this is our point B. Now we are going from A to B, such that while going from A to C the distance is x, while going from C to B it is again x as per the problem. Now initially while going from A to C it is v1 and here from C to B it is v2. The average velocity we can find as average velocity will be equals to how much here? Total displacement upon total time. So we can simply take it as 2x upon total time. Time taken to go from A to C. That will be how much? The distance upon speed x by v1 plus x by v2. Now if we take here x common, it will be 2x upon 1 here. X common here. It will be 1 by v1 plus 1 by v2. X cancels with x and we left with 2 upon 1 by v1 plus 1 by v2. Now they have said that take average velocity as v. So I am taking this A as average velocity as here v. So here it is v, here it is v. Let's cross multiply. On cross multiplying, 1 by v1 plus 1 by v2 will be nearly equal to 2 by v, and that's option B. If the velocity of a particle is v equal to at plus bt square, where a and b are constant, then the distance traveled by it in first and second is, so basically we know this is our velocity function. To get displacement or distance from a velocity function here, so that will be our x, and x here will be equals to integration of v dt. So if you integrate v velocity function, that will give us at plus bt square dt, integrating from 1 to 2 seconds. That we can further write it as integration of at dt while going from 1 to 2 plus integration of 1 to 2 bt square dt. And taking a out of the integration, this will give us integration of t from 1 to 2 dt plus b as it is integration of 1 to 2 t square dt. Because they are constants, we have taken them out of the integral. Now integration of t will be nothing but t square by 2, 1 to 2, and integration of t square is nothing but t cube by 3. From which formula? The first formula of integration, which I am writing here, integration of t to the power n is nothing but t to the power n plus 1 upon n plus 1. Now here This will be equal to a, and when you put here the upper limit, it will be how much? It will be, let me do it on the other side over here. So let's see, x will be equals to how much? A, and putting the upper limit, 2 square 4 by 2 minus 1 square 1 by 2 plus b into 2 cube, which is 8 by 3 minus 1 by 3. Now 4 minus 1, 3 by 2 a plus 7 by 3 b. That will be our displacement of this function, or distance of this function, while going from 1 to 2 second. Option B is correct. Two cars P and Q starts from a point at the same time in a straight line, and their positions are represented by, let me write here position. So here it will be xp, that is the function of time, that is equal to at plus bt square, and xq t, that will be equals to ft minus t square. At what time do the cars will have the same velocity? So first we will find the velocity of the car P. So velocity of car P will be equal to differentiation dx by dt, and x will be here xp. So let's differentiate it. That will be d by dt of xp, which is at plus bt square. And when you differentiate it, you will get nothing but a plus 2bt. And here vq is the velocity of the second car, and that will be equals to how much? dxq upon dt, and xq we have got ft minus t square. So when you differentiate this, you will get f minus 2t. Now since the question is saying that at what time do the cars will have same velocity, so we will say that velocity of p is equals to velocity of q. And what's the velocity of p? It is a plus 2bt, and that must be equals to f minus 2t. So when you equate both and take this time term on the other side, it will become a plus a minus f is equals to minus 2t minus 2bt, and a minus f will be equals to, taking t common, it will be minus 2 minus 2b. So I'm multiplying the whole equation with negative sign. It will be f minus a, that will be t into 2 plus 2b. Let's take this 2 plus 2b on the other side. So it will be f minus a upon 2 plus 2b, that is equal to time. Or you can write it as t equals to f minus a upon taking 2 common, 1 plus b. That's option D. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to the function. Let's write the function over here. So it is Vx, that is equals to beta x to the power minus 2n, where beta and n are constants and x is the position of the particle. The acceleration of the particle as a function of x will be given by, so acceleration as a function of x, in that case we will not use the formula a equal to dv by dt, but we will use v dv by dx directly, because this is also a relation between acceleration and variation of velocity as a function of displacement or distance of the position of the particle. So here we will write v as beta x to the power minus 2n, and differentiation d by dx of beta x to the power minus 2n. Now we can see that beta is constant, so we can take it out. It will become beta square x to the power minus 2n into differentiation d by dx of x to the power minus 2n. Now differentiation of x to the power minus 2n, let's write it. So that will be giving us minus 2n x to the power minus 2n minus 1. Clear? Now minus 2n we can take it in the front. So this will be minus 2n beta square, and x to the power over here, x to the power minus 2n and x to the power minus 2n minus 1. So we can make it as 2n and 2n minus 4n minus 1. So the correct result here is option B. The motion of a particle along a straight line is described by the equation x is equals to 8 plus 12t minus t cube, where x is in meter and t is in seconds. the retardation of the particle when its velocity becomes zero. So to figure out the acceleration or retardation when the velocity is zero, let's first find the time when it is zero. So velocity will be equals to dx by dt. On differentiating this, this will become d by dt of 8 plus 12t minus t cube. And on differentiation of 8, it's 0. Differentiation of 12t, 12 minus 3t square. This is our velocity. Now they are saying the velocity is becoming 0. So if the velocity is becoming 0, let's write on the left hand side 0 equal to 12 minus 3t square. And 3t square will be equals to 12 and t square will be equals to 4. Which implies t is equals to 2 seconds, because time can never be negative, you can't take minus 2. So if the time is 2 seconds, at 2 seconds the velocity of the particle is 0. Now in that case we have to find acceleration. So let's differentiate this velocity function once again. So acceleration a will be equal to dv by dt, and in that case a will be equals to minus 60 on differentiation of v. And let's put here t as 2 seconds. So retardation will be minus 12 meter per second square. Correct answer is option D. A body is moving with a velocity of 30 meter per second towards east. So let's draw it. It is moving this side 30 meter per second towards east. After 10 seconds, its velocity becomes 40 meter per second towards north. So let's draw it here. 40 meter per second towards north, and time is how much? It is 10 seconds. The average acceleration of the body. So initially we can write our initial velocity u will be equal to 30. Let's call it as I cap. East is I cap. If it is going towards north, our final velocity is towards 40 meters per second j cap. Okay. Now average acceleration we have to find. So final velocity minus initial velocity over time t. So acceleration a will be equals to v minus u over t. V is nothing but 40j minus 30I over time is 10. Let's simplify it further. It will be 4j cap minus 3I cap. That's our acceleration. And the magnitude of that will be equals to under root 16 plus 9, which will be equals to root 25, and that is equals to 5 meter per second square. That is option C. A particle moves a distance x in time t according to the equation. So the given equation here is x is equals to t plus 5 whole raised to power minus 1. They are asking the acceleration of the particle will be proportional to which one of them. So first of all, let's first find the velocity. So velocity will be equals to the derivative dx by dt. So when you are differentiating this, it will be d by dt of t plus 5 whole raised to power minus 1. We will take this minus 1 in front, and this will be t plus 5 whole raised to power minus 2. And acceleration will be equals to dv by dt. So that will be d by dt of minus 1 t plus 5 whole raised to power minus 2. So differentiation, this minus 2 will come in front and make this minus 1 as plus 2, and t plus 5 whole raised to minus 3. Clear. Now this is velocity and this is acceleration. Now we will go from answer to the question. We will see that which one is giving us the same result. So let's start with the option A. So they are saying acceleration is proportional to. Proportional means any number or constant can be ignored. Okay. So velocity here is whole raised to power 3 by 2. Let's start with the velocity first. So for velocity over here we got as minus 1 t plus 5 raised to minus 2. So ignore this minus 1 and simply put t plus 5 whole raised to minus 2 whole power 3 by 2. I have taken velocity whole raised to 3 by 2, right? So velocity is how much? Minus 1 t plus 5 whole raised to minus 2. I have ignored the minus 1 because they are asking proportionality. They are not saying equal. Okay. So we can ignore the constant term. So t plus 5 whole raised to minus 2, that's a velocity whole power 3 by 2. So if you cancel out this minus 2 and 2, you left with t plus 5 whole raised to minus 3. And that is nothing but our acceleration. So correct answer is option A. A particle moving along x-axis has an acceleration f at time t given by, so here f is equals to f naught 1 minus t upon capital T, where f naught and t are constants. The particle at t equal to 0 has zero velocity. Okay, great. In the time interval between t equal to 0 and the instant when f is 0, the particle's velocity is vx. You have to figure out that velocity. So first of all, if this is the acceleration, we can find the velocity as integration of acceleration a dt. So let's figure out. So v will be equals to integration of, what is the acceleration here? F naught. So f naught 1 minus t over t dt. So let's take this f naught outside and we left with integration of 1 minus t over t dt. On integrating 1, we will get nothing but t minus integration of this small t, that will be t square by 2. And this will be our velocity v. Now when the time is t is 0, in that case the velocity is also 0 as per the question. So this is our velocity. Let's substitute here t is equals to 0. So when you put here t is 0, let's see what we get. So putting t as 0, our velocity is, we are getting 0 only. Our everything is gone here in velocity term, right? So in that case, if okay, so that is our v in the time interval t equal to 0 and the instant when f is 0. So let's see when f is 0 what happens. So when f is 0, this first equation f is equals to 0, we can write it as f naught into 1 minus t over capital T, that will be 0. And in that case it will be 1 minus t over capital T will be 0, and taking 1 on the other side, it will be 1 equal to t over t, and small t will be equals to capital T at that instant when f is 0. So let's substitute this value, small t as capital T, and figure out our velocity. So let's substitute here. So this will be v equals to f naught, and t is capital T, minus 1 by capital T, t square by 2. So this will be how much? F naught into t minus capital T cancels out, you left with t by 2, and that will be how much? It will be f naught t by 2, that will be equals to v. That's option D. Question says a car moves from x to y. So let me write here x and let me write here y with a uniform speed, how much? Vu. Okay, fine. And returns to x with a uniform speed Vd. So let's assume that x to y, the distance is small x. So if it is going from x to y, our average speed, let me write here again the formula. Average speed is nothing but total distance over total time. Total distance over total time. So total distance while going from x to y and coming back is nothing but 2x. X while going and x while coming back. And total time will be, so the velocity is given here. So while going, it will be x upon vu. That will be the time while going, and plus x over vd. Taking x common and cancelling out, you left with 1 over vu plus 1 over vd. And that will be twice of vd vu over vd plus vu. That's option A. That's correct. Position x of a particle with respect to time along x-axis is given by x is equals to 9t square minus t cube, where x is in meter and t is in seconds. What will be the position of this particle when it achieves maximum speed along x-axis? So maximum speed means acceleration will be 0 here. That the acceleration will be negative here, right? So here we will have v, which is equals to dx by dt, and that will be equals to how much? 18t minus 3t square, right? So that will be our velocity of the particle. Now if it is achieving maximum speed, at maximum speed acceleration will also be 0, because yeah, if it is maximum it will be constant. So a will be equal to dv by dt. So let's differentiate it again. It will be 18 minus 60. and putting it equal to 0, it will be 18 minus 60, and 60 will be equals to 18, and t will be equals to 3. That will be our time. Okay, so if t is equals to 3, let's put it in x. It will give us 9 into 6 3, putting 3 here, it will be 9 minus 27. So this will be equals to 81 minus 27. That will be how much? 4 and 54 meter. That's option B. Particle moves along a straight line OX at time t in seconds. The distance x in meters of the particle from O is given by x is equals to 40 plus 12t minus t cube. How long will the particle travel before coming to rest? If it is coming to rest, velocity will become 0. So velocity v equal to dx by dt, and that will be equals to d by dt of 40 plus 12t minus t cube. So here when you differentiate, it will be 40 will be 0, 12t will be 12, and that will be minus 3t square. So putting it equal to 0, let's take 3t square on the left hand side, it will be 12, and t square will be equal to 4. So t will be equal to 2 seconds. Now this is the time. So they are asking the distance. So t equal to 2 seconds, let's substitute in place of x. Okay, so get the distance it will travel. So 12 into 2 minus 8. So this will be 40 minus 8, which is 32, plus 24. So that is equals to 56 meter. That's option C. That's our correct answer. A car runs at a constant speed on a circular track of radius 100 meter. If it is moving on a radius of 100 meter circular track, taking time is equals to 62.8 seconds for every circular lap. Okay, the average velocity and average speed for each lap is, so see here, if it is moving in a circular loop, okay, at each lap what happens, the initial position will be same, so displacement is 0. So if displacement is 0, let me write here displacement 0. So means velocity, average velocity will be 0. So first part is average velocity is 0. Distance is 2 pi r in one complete rotation. That will be 2 pi r, and time is equals to 62.8 seconds. So let's find the average speed. So average speed will be equals to total distance, which is equals to 2 into pi 3.14 into r 100 meter given as per the problem upon 62.8. So 2 into 3.14 is same as 62.8. So here average speed will be how much, or I have cancelled wrong, 1 second. There will be 110 factor also when you remove the decimal. Yeah. So here it will be 10 meter per second. That's our correct option, option C. A particle moves along a straight line such that its displacement at any time is given by, so S is equals to 3t cube plus 7t square plus 14t plus 5. The acceleration of the particle at t equal to 1 second. So to find the acceleration, velocity will be ds by dt. Let's differentiate it. It will be 9t square 14t plus 14. Acceleration will be dv by dt, and that will be equals to how much, 18t plus 14. So when you put t equal to 1, acceleration will be 18 plus 14, and that will be 32 meter per second square. Option B. Position x of a particle varies with time as x is equals to at square minus bt cube. The acceleration of the particle will be 0 at what time? So let's find first velocity. That will be equal to dx by dt, and that will be equals to 2at minus 3bt square. And on differentiating once again, we get acceleration, which is dv by dt, and that is equals to 2a minus 6bt. Now since they are saying that acceleration is becoming 0, it will be 0 equals to 2a minus 6bt. So 6bt will be equals to 2a, or t will be equals to 2a upon 6b, which is equal to a upon 3b. So correct option is option B. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at constant rate beta and comes to rest. If the total time elapsed is t, then the maximum velocity acquired by the car will be how much? Let's understand it with a graph. So in a simple sense, initially, let's say this is our velocity time graph, and it is accelerating with acceleration, okay, constant rate alpha for some time. So here it is accelerating for alpha for some time. Then it is decelerating with beta for some time. Okay, fine. So when it is accelerating from rest. So initial velocity is 0, and it is going to maximum velocity, let's say Vmax. Again from Vmax, it is going back to 0 because it is coming back to rest. And the total time elapsed while going from 0 to Vmax and Vmax to 0 is total time is t. Time t1, let's say here, and time t2 here. So let's use the equation of motion. Which equation of motion? V minus u equal to at. So here for the first one, while going from, let's call it as A, while going from O to A, the final velocity will be Vmax, initial velocity will be 0, right? So this will be Vmax minus 0 will be equals to alpha T1. So Vmax over alpha will be equals to time T1, equation number 1. While going from A to back to, let's call it as X, while going from A to X, final velocity is 0, initial velocity is Vmax, because it is going from maximum velocity to 0 again because of the uniform retardation, and here it will be minus beta. So here it T2 will be equals to Vmax over beta. That's our equation number 2. Now the question says T1 plus T2 is T. So T1 plus T2 is T. So let's substitute here Vmax over alpha plus Vmax over beta. That is equals to T. Now they are saying find the maximum velocity. So we have to find Vmax from here. So Vmax taking common, this will be 1 over alpha plus 1 over beta. That's equal to T. Cross multiplying, it will be Vmax beta plus alpha over alpha beta. That's equal to T. And this implies that Vmax is nothing but alpha beta T over alpha plus beta.